And with that, I'm very pleased to introduce to the stage three experts in three different kinds of 3D printing. We have Leslie Bush, a metal 3D printing applications engineer from EOS. Samantha Snabbs, the co-founder of Re3D, and you may remember her. She was one of the last live presenters before the pandemic made us go online. And very happy to also bring up Melody Yasher, VP of Building Design and Performance for Icon. Please welcome all three to the stage. So they're going to give three short presentations in a sequence, and then we'll bring up our conversation moderator when the three of them have presented. The first one we have up is Leslie. So Leslie, you can stand or sit, whichever you want. Here is your, that one advances it right there.
That would be useful. Good evening, everyone. My name is Leslie Bush. I'm a metal 3D printing engineer at EOS. I've been in the additive manufacturing sphere for about 7 years now, working with various different technologies, developing applications for customers, doing customer support, and also ensuring that customers can understand the technology and use it to its full benefit. So I've prepared some slides to talk about EOS as a company, some of our applications, a little bit about our history. So feel free to take a look what I have here. So EOS was established in 1989. So the company itself has over 30 years of additive manufacturing experience in both metal 3D printing and plastic polymers 3D printing. Our systems and services are essential to the digital factories of the future. We're seeing increased adoption to 3D printing throughout the world and beyond, ideally. So founded in 1989 in Kraling, Germany, I work at the Pflugerville, Texas location, which is north of Austin, about 30 minutes north of here. EOS globally employs about 1,400 employees, and we have close to 4,500 systems installed throughout the world. So we have a pretty solid user base for our technologies. And so it's about roughly a 50-50 split between metal 3D printing installs and plastic polymers. So additive, for those of you that are new to the industry and curious about this technology, offers a number of different opportunities versus traditional manufacturing, such as like CNC milling, injection molding, and what have you. There's the freedom of design. You have the capability of 3D modeling something with complex geometry that couldn't previously be 3D printed in traditional methods, and you have a freedom of design. You have mass customization. With that 3D model comes new opportunities for customization and tailor-fit applications. Functional integration. You can increase the functionality of a part without complex multi-part assemblies, and increase productivity. You can go quickly through iterations of rapid prototyping through your production and development process, all the way up to manufacturing of end-use parts with 3D printing. And so I work for Additive Minds within EOS. And so there's three different components of Additive Minds: consulting, applied engineering, and training and education. And all of these are important to the production and scale of 3D printed solutions. A lot of the components require kind of hand-holding with a customer if they might be new to 3D printing or the 3D printing technology that we provide. And Additive Minds Academy does a lot of heavy lifting with education, being able to ensure that the customers understand what the technology is about, what it can do, and how it can bring value to their use cases. So the general structure of our 3D printing technologies at EOS, they all focus around laser sintering, either the sintering of metal powder or plastic polymer powders. So you create a 3D digital model, you use software to slice the model into various profiles, and then those profiles are 3D printed layer upon layer, kind of like stacks on the cake, to develop a final 3D printed part in your desired material. And after that, you have a final part. You could do post-processing and a number of different things to the final part. And so you can start from idea to product with different manufacturing technologies: design and engineering, production, post-processing, and the final product. EOS produces all of these machines, from the Formiga EOS-P to the EOS-M technologies. And EOS, since I work specifically in the metals team, we focus a lot, especially on aerospace and transportation applications, where metals are really valuable. But we also dabble in medical, industrial applications, tooling, lifestyle and consumer goods, and automotive applications. So a couple of quick examples I'll get to. For example, Airbus A350 extra wide aerospace plane, excuse me. So this was a really great venture in that they were able to take a 3D printed assembly and narrow down a 10-part assembly to one complex part that's reduced the weight of the aircraft. It costs 25% less to produce, and it requires 16 latch shafts. It also was able to reduce CO2 production due to the lightweight functionality of the parts. You're using less fuel during transportation, and so that in turn leads to a more sustainable transportation process, basically. And so with fuel cost reduction, you can equates to significant savings of fuel costs per plane. So with ThyssenKrupp, the dual function inductor was made with pure copper using a 1 kilowatt laser. And this was able to create also a simpler parts using 3D printing. Instead of having a multi-junction soldered part comprised of multiple pieces and complex assembly, you can reduce the complexity of the part. And it also was able to reduce the cost of per part and add some value added functionality to the part too, by able to incorporate 60% less energy than typical inductors in electronic applications. And so that leads to higher productivity and to actually cheaper electronic or electricity costs. And so custom bespoke items are really valuable and a great benefit to 3D printing, or created with 3D printing. So with our polymers team, they created custom-made 3D printed frames or eyeglass frames. And so you can use mass customization using a 3D scanned inputs from like a particular person. It could be any one of us can get 3D scanned, and that data can be translated to 3D point clouds. That information on the computer can then be translated to create a model around that information that's tailor-made to your geometry and personal anatomy. And then with that, you can create custom, like comfortable items, not just for the face, but that could also be applied to clothing, to footwear, any type of wearable as well. And so there's a lot of emphasis on lightweighting, because with the benefits of 3D printing, you want to have some type of value add that traditional manufacturing doesn't have. So, like this could be manufactured in any type of way, but what brings value to this part, this lightweight 3D printed component for aviation, it could be machines, but the turnaround time for that production might be astronomical and may not be effective for like a fast manufacturing process, versus you could 3D print it in-house or through a service provider at a fraction of the cost and faster too, and with some additional benefits. When I talk about like multi-part assemblies, that's also a human factors consideration too, because if you have someone on the assembly line assembling multiple parts, there's opportunities for introducing human error and mistakes into the assembly. So in order to reduce that, you can have simpler parts, simpler assemblies, and overall a safer device. Lastly, we have another bespoke option talking about orthoses with 3D scanning and 3D printing. So we have another opportunity using tailor-made 3D scan data to allow for design freedom and also adaptability to a specific user. And so this was also made with like a polymers application. and you can create like lightweight, easy to clean material, easy to clean parts using these technologies. All right, thank you very much.
So what if I told you that the last water bottle you drank could be ground up into the little flakes you see in here, and then could be 3D printed to make the chair that you're sitting on now? This is just one real world example that our team, as well as our community of other peers, are working on as we speak. I'm Samantha. Full disclosure, I am an Air Force reservist, but I'm here today with my civilian hat on as the co-founder and catalyst for Re3D. And I'm here to share a little bit about the hype and the reality and the opportunity of 3D printing from plastic waste by sharing a little bit about our own plastic waste journey. Now, for context, we're a spinoff of Engineers Without Borders, NASA Johnson Space Center, and our time in Muganero, Rwanda, as well as in Nicaragua and parts of Mexico. And what we realized is the people we met were really brilliant. And while we put a lot of effort importing goods at cost and working with other NGOs and governments, bringing equipment and resources into countries, the people we met were quite capable. And they were interested in inspiring their own vision, manufacturing their own goods, taking control of their own communities and designs and creativity. The other thing that we noticed is whether it was in our own backyard or in Puerto Rico outside of our office, as you've seen here, or in some of these countries and communities we were visiting, there's always a lot of plastic waste. Humans make garbage. And a lot of that plastic waste, as you may have heard, is not reclaimed. So we saw opportunity to use local resources and local tools to build things locally. Now, at the time, the open source 3D printing movement in 2009 to 2012 was heating up, and new types of 3D printers were emerging every day. Seen here are just 4 different types, and Leslie just highlighted one of them that's quite popular and well supported by EOS. So we saw opportunity with the FFF 3D printers, the one that's making the little trinket up on the upper left part of this, I think it's your right, of this chart, to use FFF 3D printing and open source 3D printing to take the coils of plastic material, we call it filament, and to use it to build an object layer by layer. And so what made us different? When we started to work in these different communities and think about an open source platform that anyone could use to fabricate their own goods from waste, what we realized is the desktop market at the time made much smaller printers, and they were affordable, but you can only make an iPhone case. The people we met wanted to make prosthetic limbs, and they wanted to make composting toilets, and they wanted to make tools. Unfortunately, the industrial system sometimes can be a little bit cost prohibitive. It can be hard to source. Sometimes they're bigger and take a lot of power, and they just require more support. So we said, well, what if we could lightweight that? So to try and prove my point, I printed a green flushing toilet out of virgin material unsustainably and proceeded to pitch this concept at bars, and some of you may have run into me around town. And fortunately, there's a program called Startup Chile. You should check it out. They gave us $40K to try and make this a reality. So this is Gigabot, kind of a couple iterations after the first one. The first one's pretty ugly, actually. And it's $10,000. And it was about 20 times the size of a desktop printer. And we were so blessed that Startup Chile had a booth at South by Southwest that they were launching 8 weeks after I arrived in Chile. So they agreed if we could make it, we could put it on Kickstarter. It was funded in one day, thanks to your support, and the rest is history. So what we learned from those Kickstarter backers as a social enterprise and being open source, who are micro investors, is that people beyond Muganero, Rwanda saw opportunity in this. They were at MD Anderson Hospital. They worked for some of the biggest companies and academic institutions. And so they really informed us on the future development. And then we started to learn more about functional opportunities, whether it's with prosthetics or other applications. I would highlight too, we have a program called the GigaPrize, where we give 1 printer away for every 100 we deliver to someone trying to make a difference in their community. And those users are usually pretty invested in our hardware as well, and gave us a lot of feedback. And they said, you know, it's so great that you made a printer that's big and affordable that could take the coiled filament and print with it. But you really need to double down on that opportunity to use local resources to feed it. So we started to look around the community. We met Matt Rogi here, you see in Tanzania, who did a great job coming up with open source hardware to take plastic bottles in Tanzania to make local goods and to create jobs. These guys called Quactus in Chile that were doing a similar thing on a more industrial scale using lids from bottles. And by partnering and purchasing filament from organizations such as Fargo 3D, that we're actually making filament from plastic landfill waste. The downside is what we heard from our GigaPrize users and other community members is while that was so awesome, sometimes there's like a big plastic spool in it, oftentimes now they're cardboard, there's a lot of equipment that goes into spooling that out. It adds an extra heat cycle, which can degrade the polymer, and then you still have to source it from abroad. So people really wanted to know, especially if they're doing big things that need a lot of it, how they have consistency and potentially how they cut out the middleman. So we were hugely inspired by an organization called WASP, you should check them out, in Italy, who at the time was using dirt and local resources to build houses. They were living in a utopia. They were embedding seeds in them to make natural rebar and finding ways to repair them over time. And being NASA nerds, there was some gentleman at Clemson University that had figured out with the students how to engineer a yeast that would poop out the building blocks of plastic and what could be filament from astronaut urine. And then there was Dirk van de Kuij, best soundtrack ever. He had a sponsorship, I believe, for the Dutch government, which has done amazing things in our industry. And he was able to take refrigerators, big forms of waste streams, and to grind it up and to make beautiful pieces of furniture that were retailing for thousands of dollars. And then there's our GigaPrize community. Seen here is Chokochu Clinton, one of our, I think, our second or third winner in Nigeria. And he couldn't wait for us to come up with a way to modify the printer to print from garbage. So he started doing it himself. So through the open source community and these pioneers, as we got together, we called ourselves Trash Printers United. We were an underground mafia. Re3D started to look at the opportunity to take shredded up plastic waste and to directly put it into the 3D printer. So this is Gigabot X. This is our version of it. There's other pellet printers out there, as they're called. So where they're a little bit different is we modified the business head. So there's a big hopper, it's gravity fed. Again, we try and keep the cost low. You can grind up material and pour it in and print, in theory. In the early days, and what you may see online are a lot of snowshoes, plastic oars, skateboards, because interns supported this project and that's what they wanted. And they also helped us appreciate that 3D printing from garbage is really stinking hard. Even if you're looking at water bottles alone, different vendors, different bottlers regionally will have a different thickness of the bottle. It may have a different colorant. It may curve differently. And the polymers may have been treated differently. So we have quickly learned what we don't know about material science, and we're hiring and partnered with a lot of leading institutions. So what do? Basically, we take garbage, we grind it up, and we try and make what's called a little poop. That just getting it to come out the other end is like, it's a big deal in our company. If we can get a little poop, then we try to make a square or maybe a cylinder. And if we're really lucky, we start to get to different geometries to see how we might modify the hardware via research grants or contracts to actually make something that could have potential. So what can you print? Well, simple designs are best. As you'll see with Icon and ourselves, as we're looking at extrusion, line-like structures, continuous lines, those types of geometries tend to do really well. And there's a number of peers in our community, again, that have done outdoor installations. Usually art begins some sort of home good that begets other opportunities via defense and aerospace is kind of the trend in our industry. But there are a number of successes out there. So for Re3D as an OEM, what we decided to do is just double down on the three communities we're in. Puerto Rico and Houston, where our factory is, we'd love for you to take a tour, and here in Austin. We tend to partner with cities, a nonprofit, and some sort of integrator that can help us explore where this may have fit. So for example, in Puerto Rico, that's taking water bottles that were left over from Irma Maria and start to look at what we can make on the island. It's looking at using plastic pellets to make coffee picking baskets for farmers. Again, a lot of the opportunity for us is big, dumb stuff or little non-sexy stuff. And the resolution may or may not be there as we start to explore what's out there. But we're inspired by Carbon and Adidas as they start to look at printing from waste with other types of printers and thinking about where's their real functional and scalable opportunity. So for us and our focus since the pandemic, pre-pandemic and during the pandemic, has really also been doubling down on manufacturing waste. It's clean, it's typed, it's consistent, and there's a ton of it. Seen here is waste that I unsustainably brought up from Puerto Rico from a major pharmaceutical manufacturer. They go through thousands of these a day. Just having downtime on their line costs millions of dollars. They spend thousands of dollars on fixtures. They're very interested in not paying to dispose of their waste off the island and using it to make something that they could need, or potentially for a tax incentive. The Army's also been in this conversation. Seen here's Nikki. Her and her team have been looking at all the hardware associated with printing from plastic waste on a base. And there's some other open source pioneers that we admire as well. But what all of us struggle with is there's a lot of other equipment that goes into printing from waste. You have to find a way to make your garbage smaller to go into the printer. You may have to sift it, you may have to wash it, you may have to store it, you may have to dry it, and then you have to figure out how to print with it. And if you're going to print something big, you need a lot of it. So how is it going to feed? How is it going to be automated? How are you going to do that training? So during the pandemic, Icon, a lot of other companies are really pressed by the Department of Defense to start to think about expeditionary solutions. So this is our version. We call it the Giga Lab. And it may or may not have filament printers or pellet printers, but allows you to have all that hardware you need in a more mobile footprint. We're honored now to have a contract with the Puerto Rican Science and Research Trust, the Air Force, the Army, and the National Science Foundation as we figure out where this makes sense and how big of a printer you could actually put into it. So why do this? Well, one, there's a effort towards nearshoring right now for a number of reasons, primarily driven by sustainability. It also allows you to have this resource and move it around as needed. It's a form of project-based learning. So maybe you use waste in a municipality with one university, and then you move it over to another school when they're ready to transition that knowledge or the training to another location. We're not the only ones in this space. I do want you to take that away. There's groups such as Audi that have been looking at using their own manufacturing waste to make tools that are saving thousands to millions of dollars every day around the world. And we get so much inspiration from them. KLM is taking their own bottles to make filament with a company we really admire in the Netherlands that's then making tools that they need. And us, like ICON, like EOS, and so many of our peers are really excited about the future of space. NASA has, and other space agencies have doubled down on using natural resources and waste, which promises a really interesting conversation. We're also really fortunate to have 3 NASA awards now looking at printing from garbage going around the moon in the Gateway program. So with that being said, what I do want to impress on you all is 3D printing from garbage, or what any of us are doing, requires a huge ecosystem. If you're excited about additive manufacturing, there's a home for you, whether it's in the training, the materials, the design, the product, the standards. The opportunities are endless. It's a very nascent industry in a lot of ways. So we really look forward to your feedback on what you would print from garbage, or what you would print in general, as we continue to explore sustainable and locally driven manufacturing together. Thank you.
All right. What a fantastic set of presentations, right? That was awesome. Please give them all another round of applause. And it's not over. Now we are very pleased to bring back our former managing director for the Austin Forum on this stage for the first time in 2.5 years. I wonder what she's been up to. Jessica, waddle up here and tell the audience what you've been up to.
So good to see you. I clearly haven't updated my Facebook page picture in a long time. I look a little different. Thanks. I'm so excited to be here. Thank you, Jay, for asking me. Thank you, ladies, for letting me join in on this conversation. And I just want to say how especially meaningful it is. My husband and I are expecting our first child, which is a baby girl, in November. And so to get to be here with these women in technology, it just feels like a blessing to us. So I just had to say that. So Jay, how much time do we have? 30 minutes. Okay. Are you going to do a little dance when I'm at the 5-minute mark? I want to dance, but okay. Well, this is my first question, which is, and some of you have talked about the different things that they're using for 3D printers. Is there going to be a universal 3D printer where you can just feed it everything you have around, whatever you have around, and it's going to perform the chemistry that you need to fill the desired objects? And I'm going to ask questions and just ping in too as appropriate. But I saw you pick up your mic first, Samantha, and so.
Usually like to go last, but I will say, feel free to let's banter. I don't think so. At all. I think that just like you have a hammer and a crescent wrench and a Phillips screwdriver, 3D printers they're all different tools, right? They're specialized for different applications, especially as we think about where the opportunity is. And what I think is so cool is you see our technology side by side when we go to Oak Ridge National Labs or wherever in the world. And I think there's a reason for it, and it's really beautiful. But I personally don't think so.
Can anybody give me hope that there's going to be a universal 3D printer?
Personally, I would hope not, just because it would be an unwieldy machine to work with, like a Swiss Army knife of so many different tool heads and specifications. It would be really difficult to have that work successfully. Like say, for example, like a lot of 3D printers have very specific specifications, and also the materials that you're printing with have specialized environments and needs basically for production. Like say if you took a 3D model and then try to print on one of EOS's machines versus an Icon machine versus a Re3D machine, there'd be so many different variations on what that technology is capable of printing, the size, the scale, what materials are available. It would just be, it wouldn't be consistent, and it would be very difficult to kind of even like install in an environment. It'd be like very large, very expensive equipment to do everything.
Yeah, I agree. I think 3D printing, unfortunately, is a materials engineering challenge more than anything.
Okay.
And the printer is in some ways designed for the material. If not, you engineer a material for the printer. And so they're intimately linked. And the idea of one serving multiple materials or multiple tool heads or whatnot is hard to believe, but I do like the idea.
I will crush that dream right now. It's okay. I was just curious. So while things like AI have exploded into awareness and popularity, it doesn't seem like, I would say, at least from the perspective that I've seen, that has totally happened with 3D printings yet. But again, Samantha's like, yes, it has. And why not? If you think that way too, why not? Are there specific factors holding it back from having exploded into the awareness of everybody? Let's go backwards. Yeah, let's go in reverse order.
I do know that there's quite a bit of work in machine learning and AI and machine vision when it comes to quality control of 3D printed parts. And so that's there. That's for sure happening. But on the design side, like when it comes to like designing something that was AI generated and having it self-print or auto print, we're not there yet. No, unfortunately, these machines are not that smart, or maybe that's a good thing.
Probably.
But it's an interesting thing, that idea of like self-assembly, kind of like auto generation. These are ideas that come up when we're talking about 3D printing and what it means to like create a replicable machine that can kind of print itself. That has always been the end all be all dream of in particular the product landscape. Like, can you print a circuit board that has a robot walk off the 3D printed bed itself? Like, can we imagine that future? I don't know.
Should we? I don't know. Yeah. I'm curious too. Do you see the chat GPT like moment that or even more rapid increase in adoption and awareness? And if so, what might have us be on the precipice of that, or what might put us there?
I guess in my experience in like the digital fabrication space over the past decade, I've seen kind of two events that have spurred some of that in the 3D printing sphere. One being in like around like 2008, 2009, 2010, when there was a series of specific patents inspiring the industry that allowed like the beginning of the maker movement and the open source 3D printer movement, where we were seeing desktop 3D printers available for the first time at relatively affordable costs. When I was in college in 2008, our shop technician actually purchased a MakerBot 3D printer, and that was like a very popular desktop 3D printer that was like affordable for schools and people who really like expensive gadgets. Like it was a microwave size 3D printer around $2,000, and it was like a DIY kit that you could assemble yourself at your home or in a workshop, and you could 3D print parts. But now we're seeing like a rapid decrease in costs. Like I have a couple 3D printers now at home, and you can get some for about $200 now. So you're seeing like a huge adoption and rapid prototyping for consumer and hobby level. But then I'd say for kind of industrial grade 3D printers, the pandemic also opened up a lot of, I guess, applications for 3D printing, unfortunately. Like during like the onset of the pandemic, when there was all those supply chain collapses, there was a need for PPE and face shields to be developed, nasal swabs. A lot of 3D printing companies were able to step in and 3D print those crucial supplies without like if you had the material in stock either on site or locally, it was very easy to print those and then send them to hospitals. And then the material requirements were beneficial or I guess like were good for 3D printing too, because you needed like materials that could be autoclaved and easily cleaned and sterilized for repeated use in the hospital. So I'd say like there's a lot of like industrial applications seen were brought to the forefront during the pandemic.
Beautiful. When do you see that the customer market might move more towards a consumer beyond the hobbyist level? Like, do you see that by doing more ordering and designing online, by everybody having their own installed at home? How do you see that sort of a general adoption happening?
As an OEM, I think we're similar in the industrial space in that it's about education. We probably tell more people not to buy our printer than to buy it because you want to make sure it's the right tool and that they're prepared. And most of us will do materials testing or contract printing on our printers as a service and kind of a sales funnel to make sure that it's good. But ultimately, when you think about real scale, even down to the commercial level or for industrial applications, a lot of it comes down to qualification and certification as well. So you're in parallel always trying to learn about that whole ecosystem, not lobby, but advocate and participate in standards discussions.
Yeah, I definitely agree with the education or technical education being very important because I guess there's a misconception, I guess, sometimes in marketing or I guess in the general population that you can plop anything on the 3D printer and print it. But there's some more considerations for each technology and each material that you're trying to utilize. So that's one of the components of my job too, is like educating the customer that this makes sense for their application and like the business case actually makes sense too.
That actually has me want to ask a different question too, which is, what do you see are the misconceptions about 3D printing and its applications? And then also to piggyback on that, like how do you see any ethical, what are the ethical concerns you might be hearing about or seeing, and how might you be working to abate them? Any misconceptions? We can break that down into two questions first. No. Sure. When she was talking about misconceptions, so that what are the misconceptions that you see hear from people about 3D printing? I asked if there could be a universal one. You clearly told me there cannot be, so I now know. But with the general public, are there misconceptions about 3D printing in particular and how it can be used and adopted?
I can speak on our end. I think people believe it's magic sometimes when they see it.
Sure.
No, really. And there's an assumption that this technology is a lot smarter than it actually is. Like the mechanism of a gantry style printer, for example, is not that complex. And there's not a lot of like inherent intelligence in that system to know where it is and what it's doing as a robot, for example. But I think that consistently that is like the thing which other folks misconstrue, but also there's like an element of wow, like it's moving on its own. I can't believe it. Like that's the thing which I think people repeatedly are sort of mesmerized by.
We always like to remind ourselves when we're printing and our community that the robot does exactly what you tell it to do. That's a very humbling thing most of the time.
You give bad directions, the robot has bad directions. Like if the robot makes a mistake, it's your mistake. Are there any like ethical considerations associated with 3D printing technology, IP concerns, environmental impacts, gun printing? What are ethical concerns people might need to be aware of?
Yes, there are ethical concerns, especially when you mentioned gun printing. Unfortunately, there's actually a local guy.
I know.
You could probably Google his name. I won't say his name, however, but he's famous for or infamous for creating like an open source model of a 3D printable gun. And he created like his own company, his own 3D printer, and his own files to 3D print like I guess usable guns. I would never touch that. I wouldn't trust the reliability of a 3D printed gun, but like that is a concern of having almost like ghost weapons that can be like easily transported without detection. So that's definitely a concern. And I know like companies I've worked for, like stray away from like certain applications like that.
Yeah, it's a tough one. Someone told me once to say, which I shouldn't say, that like Gutenberg invented the printing press, so he's not responsible for pornography. Because we've been getting this question since we founded, and it's tough. I would say, we don't sell cold. Most of our sales are inbound, and we have a high touch with our user to find out what their interest and goals are with the machine. I can't speak to every OEM. Because our machines are a little bit bigger and higher priced, it's lower volume, so we can do that. But it's a tough one. It's something that I think about. I'm sure our teammates have, and our peers in the ecosystem, in understanding when essentially we're making a tool, right? Where your responsibility lies and how it's used. In terms of like, there's some interesting things right now, some of the industry conferences we go to around like counterfeiting and ensuring authenticity. And my favorite recently, I was speaking at a climate event, and I was at this roundtable. I think he was from BASF, and he was saying how, in addition to blockchain, which is often getting applied to help think this conversation through, they have these ancient salts, and each one is unique. So by like embedding a certain salt into your feedstock, you could ensure a chain of custody and authenticity of designs as we scale. Because a lot of us that like have a land and expand strategy. So between sites, ensuring that things are true. But yeah, there's a lot of ethical quandaries in 3D printing, and what I hope is that the dialogue continues because it's ever evolving.
Going back to how we can best support the growth and development of 3D printing, how do you see that governments and regulatory bodies can collaborate with key industry players to support growth in 3D printing? You represent, a really global and now galactic approach to 3D printing. So how do you see those partnerships working?
So you're asking more about like how we can foster these partnerships?
Well, and specifically, like how can governments and regulatory bodies best work with with your organizations as well to support 3D printing and the breakthroughs? If you have thoughts on that.
Definitely any way to support grants to bring like additive manufacturing or improve manufacturing in general efforts in the United States. Like, there's a lot of talk about like bringing manufacturing back to the United States. So, partnerships that can actually foster and support like various different companies who are like producing their own software, producing their own equipment in the United States, getting them like government's financial assistance would be beneficial.
Yeah, I was going to say the same. I think research is number one, and supporting small businesses, minority-owned businesses, and developing new technologies that can enhance the state of the art. That's definitely one way to help with the status quo. I think regulatory bodies are there for a reason. Of course, like we have many regulatory challenges working in the construction sector, and that's for good reason, right? Like there's a certain standard of care that you have to introduce both architecture and construction. And because it's like we're developing a new building system, there is not international building code available for 3D printed buildings. So what do? You're kind of ahead of the curve when it comes to engineering guidelines and standards that have been developed. And so we try to be as active as we can in maintaining relationships with different jurisdictions, regulatory bodies, standards committees. And it tends to be pretty exciting, frankly, because, sometimes you have folks who have a lot of confidence in a new system and you have folks who do not. And so you've got to have the engineering and the science to back up what it is that you're doing and hopefully propel the entire industry forward.
Yeah, I was going to foot stomp on standards as well. Ultimately, everything comes down to that. And I have daily, my appreciation for standards is growing, but a lot of times there's more than one committee or organization that also informs that standards, which can be really exhausting, like as a small business like us, to figure out, where you weight your time and how you participate, and what technical event that starts to shape those conversations. But anything the government can do to break that down. I think also like there's a great movement now through America Makes and other organizations to give our companies more access to resources like at national labs and beyond. So anything you can do to provide more access for companies that are creating materials, creating hardware, containing processes, and all these other things to leverage those resources locally or nationally, I think is really helpful. And then finally, I would say, we don't give them a shout out enough, but for anyone knows Karen Parker and U.S. Commerce, like for what we do, as was pointed out, U.S. Commerce has a big lift in the Department of Transportation. Like there weren't codes even when we started in 2013 for exporting. We were all randomly assigning labels and hoping we didn't get fined. And on more than one occasion, I've had a printer held up at an embassy or by law enforcement in a foreign country, and I have to figure out how to get a hold of an ambassador and like change the policy to get something into the market for the first time. So, there are, I think at the national level, there's other organizations too that really curate our success so we can plant that first flag and support and get the visas, those first customers with the training that is just as significant as, other dialogue nationally.
Got it. And then to people who are in the business sector and across different businesses, how do you believe that 3D printing is reshaping traditional business models and supply chain? And why is it crucial for business owners to stay informed and consider integrating this technology into their operations?
Yeah, I think there's huge potential in leveraging communities of engineers and designers to think differently about standard parts and industrial scale kind of applications. And hopefully, I mean, the reality is that we're still in the early days of all of this. So the idea of hiring someone to rethink your mechanical engineering or whatever it is that is sort of like integral to the work that you're doing, and optimizing that for 3D printing that doesn't always get considered. I think there's still a lot of fear and risk associated with incorporating additive. But I mean, the larger aerospace aviation companies are demonstrating, at least in my experience, that it's definitely possible. And yeah, it's an exciting thing to consider for smaller businesses in particular.
Yeah, I think it can completely rechange workflows. I'm from Detroit, so a lot of my references come from there. But my dad works for runs the lines at Detroit Thermal Systems, and 100% of their inventory goes through every 24 hours and all their supplies. It just blows my mind. And I have a really dumb example in that they get one component for another component, and it has a little plastic cap on each end, and they get thousands of them a day, and those all get thrown away. And then they put a cap on it. It goes 2 miles down the road to Michigan Road Plant for Ford, and the new cap then gets thrown away. Like it's just so much waste, right? And yet they buy fixtures for $25,000 each that are sourced, that take weeks to get and sometimes aren't right. And when they have downtime on a line, it costs millions of dollars, not to mention their line workers. Well, maybe not right now because there's a strike, but like they consume tons of water bottles a week. But just thinking about like new business practices in manufacturing where from a circular model, you're creating efficiency and you're iterating faster using your own resources you otherwise pay to dispose of, I think is really opportunistic. And then like thinking about General Motors, like when they incorporated additive into wind tunnel testing, I think they were able to cut their wind tunnels down, I'm going to screw this up, by 1/3 or 2/3 of the size. Running a wind tunnel is not cheap. Not to mention how they normally did it is they had these like big clay models, right? And there were tons of worker comp claims and issues, union claims too, with like back injuries. So now they can have these smaller scaled models that are 3D printed, that are lightweight, that are improving workers' health and saving all the energy around wind tunnels and getting to market even faster with new production is really cool. So, those are like a mid-size and a larger size company example, but I would say, it gives you that license just to be really creative and think about like, what if, and what are the second and third order effects that double, triple value add? But again, it's not always a great solution. It just kind of gives you that opportunity to kind of like, start clean if you have the appetite for the risk and you have the resources for the capital outlay.
I agree as well. Like with your statement about like increasing efficiency and productivity. Because that's like a huge component of my work, because I'll have part of my work as an applications engineer is having your prospective customers come to me with various parts and they're interested in 3D printing, but some of them may not have like the best case scenario for it, or we try to create a cost per part. Like, how's the cost per part of 3D printing this compared to how you previously been manufacturing it? And like, of course, we want to make sure that the benefits outweigh the risks, or like the initial cost of purchasing a 3D printer and getting your facility up to spec. So ideally we want to improve those efficiencies and like reduce like human factors issues, like you said, with like injuries in the workforce, or make something low cost but quality and out the door a lot faster. So like these considerations are very important for like adopting both like locally and like internationally too.
Thank you. And then, oh, there he is, Jay. Well, I think we're good. We got through there's always more questions. Thank you, ladies, so much.
We're not done yet.
Okay, you're not done yet. Just kidding. But we take more applause.
All right. So what's that? Not yet. We're almost there. Thank you, Jessica, for coming up and asking those great questions. I hope you got something out of all three presentations and out of that wonderful facilitated conversation, but we're not quite done yet. As always, we take a few questions from the audience, and we always believe in diversity at the Austin Forum, but I think we see there's a distinct lack of diversity on the stage right now. There's no beards up here. So with that, John Lockman, our technology director, please welcome John to the stage for the audience Q&A.
You're gonna bring some beer to the stage. All right. No, good questions already, but there were a few from the audience that we didn't get to cover that I thought were kind of neat. Is there anything interesting about printing in 0G that's a lot different from what we have to do here on Earth?
Someone that's flown like 60 loops, first of all, you have to try not to puke while you're doing it. But yeah, there's a lot of things like for our hardware, and our teammate Patrick Farrell, hit him up on LinkedIn. He can talk your ear off about it. But traditionally we use gravity. In space, you're using reduced or not gravity. So for our system, it's gravity fed. So we had to come up with basically a cartridge and a way to like inject material in, right? So you can get around that. Also in space, sorry, I have a lot to say about this. I've applied to be an astronaut 4 times, full disclosure. So a lot of the materials in there are fire retardant, right? Well, when you melt something that's fire retardant, it can kill you. So you have to think about like a closed chamber that can allow you to process that material without harming, we call them the crew members, AKA the astronauts. And then additionally, you got to think about fire. Fires in space are really bad, especially in the ISS. If you've seen it, it's crowded. There's a lot going on up there. So yeah, when you think about 0G, you've got safety requirements, you have the human factors with the crew member, and then you have no gravity, and actually making it so that an astronaut, when like every single second of their time and sleep is scheduled, is getting the most out of that and the highest likelihood of success. It can get really challenging and really exciting. Also, NASA's old, a lot of beards work there, and there's a lot of rules about what fits in a double mid-deck locker. So you've got to like comply with all the paperwork too. I'll let you guys go, but I get really passionate about space. I'm so excited to see us all print in space at some point together.
Yeah, definitely the considerations about no gravity is super important. Like for like EOS's technologies, it's all powder-based materials. So, like, in our environment with gravity and everything, the powder doesn't move that much. But, like if you brought that 3D printer into outer space, the powder would just go everywhere and you would have nothing for the laser to hit properly. And also the technology also uses basically like what's called a recoater arm to spread a layer of powder that's like very thin. Like, for example, the diameter of a human hair is about 100 microns. And like some of our layer heights are like 40 microns. So these are very exact, very precise, thin layers. And if you can't get that exact layer thickness, you get inconsistencies in your part. So basically just having powder flying everywhere wouldn't be effective. So you'd have to have anti-gravity system to like make it efficient to print.
That's wild.
I can jump in about the lunar surface since that tends to be the application that we're thinking about. Crazy temperature swings, the lack of an atmosphere, and of course, all of these challenges with being in a kind of unpressurized environment with no gravity, like very, very challenging.
It sounds like the next fun challenge, right? And that was a question from David Smith. I got another one from Craig Worth in here, and he's asking, what are the big changes that we should see in the next 5 to 10 years? What's the biggest impact on society and environment that I think that everyone in the room will see around them? What do you want to see the biggest impact of?
I'd say I could see, the next 5 to 10 years as, we improve, like machine vision and AI enforced software, easier ways to troubleshoot 3D prints and also to get like repeatable quality parts. Like having, like say like a smart camera that can inspect every single layer, check for defects, or even check for potential issues before they occur in the printing process. Because that's very important in like aerospace and transportation to have quality parts that are qualified. And so having smart systems that can reduce, like imperfections in the parts is very important. Like say like an air pocket or some type of inconsistency in the part could cause part failure. And if you're using it in space or using it in transportation or aeronautics, that could be someone's life. So it's very important to have quality parts.
More reliability.
I think there'll be a lot of improvement on the design side of things too, and the material science. Material science is quickly catching up, and that's where I think as OEMs we're like chasing our tail, trying to keep. Yeah, I think there'll be new materials. The standards obviously will evolve, but I think in the next 5 years, what I'm cautiously optimistic about in the US is, particularly for the OEMs and even the academics, a lot of us and the materials providers were kind of in our silo, just doing our own thing, trying to prove this niche and just survive, quite frankly. It's a tough industry. But there's a lot of movement now towards getting us together, having shared spaces to collaborate, to come up with those use cases. A lot of times, like if you look at an airplane, there's more than one 3D printer that printed parts on it, especially with EV right now too. So just kind of providing that sandbox to grow together and to reinforce those relationships in the ecosystem. That's what makes me really excited. And I think there'll be like centers of excellence probably around the US that will spring up around those different additive manufacturing communities.
I think on the construction side, it's having a better idea of the carbon footprint for the materials that we're using, and engineering smarter, better materials is inherently part of that, which will support additive definitely in the future. And I think to your point, like connecting the right people for the right problems to solve the right problems and empowering them to do so is really something that I hope larger industrial scale kind of product manufacturers will support and encourage. And yeah, I think that will help us get to a more sustainable future faster.
That's awesome. Thanks. Is Gwen Juris here in the room? All right. I got a winning question here because I like that it tied in all of these together. We're printing with metal, we're printing with concrete and maybe Mars dirt. You're printing with garbage. What are the most challenging materials to print with, and what do you think are the most promising for the future? I mean, garbage, obviously, but what else?
In my personal experience, like I found metal 3D printing to be the most surprisingly challenging. Working at EOS has been my first introduction to metal 3D printing. I've worked primarily with plastics and resins previously, but there's a lot of like safety requirements needed in order to like 3D print metal parts because there's oxidation involved. Like you want to have an inert environment when you're hitting a laser with metal. You have to have like anti-stats, like mats and shoes in order to prevent like a spark that could potentially cause an explosion. And then, additionally, I'm wearing PPE like respirators, so I avoid inhaling these small particulate metal powders. So it has a lot of like considerations needed in order to properly like 3D print, but you get really amazing results.
I think the thing that I'm most excited about, and which is undoubtedly very challenging, is this idea of multi-material printing and introducing complex parts that incorporate different materials within the assembly itself. It's something that is going to be, it's already inherent in the way that we design our wall systems. Like we incorporate insulation, we incorporate reinforcement, but not all of those are 3D printed, right? It would be fantastic if they were, and we're working towards additional automations that can support that. And that will apply at every scale, not just in construction, but also at the product scale too.
Yeah, that definitely, I concur. That's, I think super, super exciting. Short term, I would say, yeah, anything that has flame retardant, for any of our applications, is challenging. Again, thinking about off-gassing things that could be carcinogenic and how do you scrub that and close that loop? And then in the waste conversation, some of the waste streams that people are most excited about are just really terrible to print with. So like HDPE, LDPE, polypropylene. We have, actually I was doing it at UT today, but we have a printer there, and we have a project with the Air Force Academy, and they've come up maybe with a hack for that. They call it artisanal waste. So if they can get to a little poop or extrusion, which you can with those materials, but they just traditionally don't print objects well together because of their properties, like pulling on itself, blah, blah, blah. They've come up with like just really simple designs that they can print. Then they bury it in the garbage or in the ground to support soil stabilization, which I don't know what you guys all think about that from a sustainability perspective, but I find it really interesting of like, if you can't beat them, join them with some of these tough materials, and at least find like a better way to manage it.
Yeah, hey, if you can't get rid of it, we found a use for it at least. Awesome. Well, thank you, Gwen, for that question. And Jay, I'll hand it back to you.
Let's keep that applause going for all of our speakers. They did a fantastic job tonight. Thank you all. Thank you, Jessica, for coming up here and moderating.